Hello, Mr. Andy here. This is part 2 for week 3. We have this part up. We looked at this in week 1. We talked about this in lecture. Again, a lot of features here for a simple part. And we talked about where to begin. And again, because all the dimensions come from the center of the part, all the vertical dimensions for the most part, we decided it'd be nice to have that geometry in there. So we made this the origin and this the base feature, which you can see over here on my screen. I've already sketched it. The other thing we have to take note of is that this part, if we think of it from front to back here in the right side view, there are no dimensions describing the relationships between this feature, this feature, this feature. It is assumed by looking at this that these are all symmetrical features from front to back. What that means for us is when I extrude, think of this sketch plane right here for my first feature. When I extrude that, I can't extrude it in a single blind direction. I'm going to have to do all kind of mid-plane extrudes here off the front plane. It's the only way this part will come together because I don't have dimensional information establishing, say, the relationship between this edge and this edge. So we have to assume that everything is symmetrical or mid-planed on this part. So let's have a look here. I have the sketch done in SolidWorks, and I'm going to extrude it to get the 2-inch depth here. So we're going to do feature, extrude. We're going to go 2 inches. However, again, I have to go mid-plane on this one. I have to keep the origin in the center of the part so I can work from that. I'm going to hit OK. Now, in order to show you an interesting feature in SolidWorks, I'm going to intentionally do this wrong. I'm going to do this in the wrong order just so you can see how history works in SolidWorks. So I'm going to do what you should not do. I'm going to click on this front face and start a sketch. I'm going to go normal 2, and I'm going to put these 2 holes in. So we're going to draw a circle here. I'm going to touch the edge, and on that center point, draw a circle. I'm going to dimension those right now because they're both diameters. The first is 0.5, and the second is 1.38. Now I'm going to add that notch here. Reacquire and come straight down. I'm going to trim that out. I'm going to add a center line here from the midpoint straight up. I'm going to make that a vertical center line, and then I'll put a couple dimensions in here. This is 0.25. I know that's off the screen, just trust me. And this is 0.44. All right, I have that shape now. I'm going to cut it through all. Hit OK. Lovely. I have the center kind of hub of this part. All right, now we have some decisions to make. I have this cylindrical feature going through this way. I have a cylinder here. There are different ways to do this part, especially if you knew how to use the plane tool, but we haven't talked about that yet. So this cylinder right here, we see the circle here for it, has a diameter of 1.75. Well, we don't know where the top is. I mean, we do know, but I'm not going to show you how to create a plane. So we're actually going to sketch that right on the origin. So I'm going to go to the top plane and start a sketch. I'm going to do a circle right on the origin. I'm going to dimension that circle. I just hit the D key to do that at 1.75. Now, I like to work in a 3D view. I try not to go normal 2 just because it's extra steps. So once you get better at judging what's going on, you can do that. But if we spun this, you can see, you know, it's kind of where we expect it. I'm going to extrude that now. 2.75. Now, I think you can immediately tell that I have a problem with my model because I just plugged up half of this hole and half of that hole, or all of that hole for the most part. So here's a rule for you if we haven't talked about this yet. The rule is you should do all of your cuts last in your model. So what I'm going to ask you to try and do throughout the semester is to create the solid form first, all of it, and then do all the cuts. This will always keep you out of trouble. It also makes the model easier to edit as you get down the road. So cuts last. But I'm going to go ahead and keep working on this one just for the fun of it. So I'm going to go to the right plane now and start a sketch. And again, right on that origin, I'm going to draw a circle. I'm going to dimension that circle at 1.13. That's off the screen for you. And hit enter. And I'm going to extrude that 2.88 inches. It's right up there. And midplane it. Oops. Let's try that again. 2.88. And there is that feature, and we've put another plug in that hole. Next up, I'm going to create this rectangular body that's in here. You can see it's this deep, about 0.94, and it is, again, we don't know where it ends and begins, so we're going to start it up here at the origin, and we're going to take it all the way to here because I have that 3.75 dimension. You could do this cylinder first. Those are acceptable methods. Do be careful. A common mistake in this part is to get this dimension in there twice, and we don't want to see that, so be careful. I'm going to do a rectangle. I can actually do this rectangle on any of the three principal planes. So from the top plane, I could sketch a rectangle that is 0.94 tall and this wide, 1.5 wide. On the front plane, I could do a rectangle 1.5 wide and the 3.75 tall. On the right side plane, I could do a rectangle 3.75 tall and 0.94 wide. Doesn't make any difference. I'm going to show you a couple rectangle tools just so you can see different ways you could do this. So let's try the top plane first. Start a sketch. We'll go normal 2 on this one. I'm going to click on rectangle, and I'm going to do a center point rectangle there. That takes care of all the relations for you, so I can just dimension this at 1.5 and this at 0.94. It's fully defined. I can now extrude that down other direction here. 3.75. I'm going to get out of there. I'm going to cancel that sketch. Let's look at the same situation from the front plane. So let's go front plane. Start a sketch. We'll go normal 2. I'm going to do a rectangle. I'm going to do something rather odd. I'm going to stick it out here in space. I did a center point rectangle. I didn't need to. I could have just done a regular rectangle. So I deleted that geometry. I'm going to go ahead and dimension it, believe it or not, at 3.75 by 1.5. And then I'm going to create a relation between this line and the origin, a midpoint relation, and snap that into location there. Now we'll extrude that. We're going to go midplane. Whoop. By the way, don't ever use that. Midplane. There are uses for it, but not in this class. Midplane extrude 0.94. Make sure that looks good. We'll hit OK. Finally, on the front plane, I'm going to start a sketch. We'll go normal 2. I'm going to draw a circle right on that midpoint. Dimension it. 2.56. And I'm going to extrude that. I think you can see it. Extrude it. Feature. Extrude. Midplane. 1.31. That's off your screen, but don't worry about it. Check. Now again, I've now completely plugged up the holes in the middle, right? I can't see through there. And I said, well, we should do all our hole cuts separately, and we should do them last. Let's see now how history works in SolidWorks. This doesn't always work, so this will look really cool, but sometimes it won't happen. The cut extrude was done in time, if you will, as the second step. Well, it really needs to be the last step in this sequence here. Okay, so I can move this as long as none of these features referenced any of the geometry for the cut. So if I dimensioned off the edge of something in that cut, I can't do this. But if I haven't referenced any geometry in that cut, I can change its position in time. I can make it happen after extrude 5. And all I'm going to do is click on this and drag it. And if I get that little arrow, that means I can drop it in between there. So let's drop it right there, and you'll see that now I've gotten back part of the hole because it happened after these two extrudes, but still the rectangle's in the way. So I'm going to go ahead and pull that down all the way to the bottom. So the cut is now the last thing, and you can see that my model has healed. Okay. So that's how historical modeling works, in that you can sometimes change the sequence of history here. Now, you will do some more cuts. I'm not going to do those. Again, do each cut as separate features unless they're on the same face like these two. So this will be a separate cut. You'll have a separate cut here. You'll have a separate cut up here. I will show you this one just because it's a feature we haven't used yet. I'm going to start a sketch. We'll do a circle here. We'll dimension that. 0.88. And now I'm going to cut that. Well, how far do I go? I've already used this dimension. Can't use it again. We don't want two dimensions in the model. So I can't give an extrusion distance here. I certainly couldn't say through all. That would kind of cause some problems for us. So this is an up to, maybe up to next will work. It looks like it would. You could also go up to surface and pick that inside surface, and we'll hit OK. So there we go. All right. Now I do want to show you the fillets. If you look at the drawing here, somewhere on this drawing, right down here, all fillets and rounds are R1. 0.1, and everything is filleted that's not a flat exterior face. So we have all these machined faces, all these exterior faces, but the edges of the rectangle, where it joins this, where it joins here, where this cylinder joins the body, all these connections where these are joining, those are all filleted. We haven't really looked at the fillet tool yet, so let's take a look. We're going to go to fillet, and we're going to set it to 0.1. It's already there. And you have a couple choices with the fillet tool. You can pick corners, like I'm doing here. That's one way to approach it. However, on a part like this, where certainly all the corners are filleted for the rectangular flats, let's try doing a fillet. And we'll just pick the faces. I'm going to still pick all four, but it's a lot less clicking. Then this is filleted. And notice it can't complete the tangency here at the top corner, so you got to pick that to get that fillet to show. If you lose the preview, when you click that, if the preview of all the fillets goes away, you know you might be in trouble, or you might just be missing a piece. That's going to make that one happy. I'm going to pick this corner. This is a commonly missed corner. This piece is filleted right there, and then I'll pick there, and here, and here. And again, it gets a little confusing. We're going to try and do this all in one command so that it's easier to edit. And if it doesn't blow up, I think, let's look here. Oh, we're missing one set of corners here. Again, another commonly missed location. Those bottom edges on the... Now I think we have everything. We'll hit OK. And that puts those nice, lovely fillets in our part. Okay? So there's the fillet tool for you on this part. All right, let's throw that away. And lastly, let's scroll up. We have this part here, and this is a rather odd, compared to how we've done it so far, odd way to create a part. Sometimes we would like our part to represent the exact steps of the manufacture of the part. So it gives you a totally different approach to modeling in SolidWorks when you're trying to represent the part exactly the way that it was machined, if you will. So I'm going to make this smaller so we can see it. And it says here, begin with a solid extruded cylinder, 5.12 in diameter by 3 inches long. That's the whole length of this part. But then everything else is cut revolves. Okay? And I'm not going to do all of this, but I do want to show you what that looks like. So we're going to do a new part. This is an inch part. We'll assume this is the front, so I'm going to go to the front plane and start a sketch. And we're going to draw a circle with a diameter, whoops, of 5.12. And we're going to extrude that 3 inches. So this is like our solid chunk of stock material that we're going to use to make this part. Now I want you to imagine that we're going to put it in a lathe, and we're going to have to turn it around once if we put it in a lathe, and we're going to machine everything else for the most part as if it were done on a lathe. So I'm going to go now to the right plane and start a sketch, and I'm going to go normal 2, and I'm going to draw a rectangle from the back corner, and I'm in the wrong rectangle style. So let's get back to a corner rectangle. From this corner, I'm going to draw a rectangle right here. I'm also going to draw a center line. I'm going to need that center line. You're going to draw a lot of center lines in this part. I'm going to dimension from here to here. That diameter, that's what's left here, is 2.06. And then I don't know how wide the rectangle is. That's this distance, but I do know it's 2 inches back from the front edge. So I'm going to go from the front edge back 2 inches. It's fully defined now, and I can cut revolve that around that axis and whittle away that part of the part. Okay? And you're going to use the same process for each cut. So I'm going to go back to the right plane, start a sketch. We'll go normal 2. I'm going to do a rectangle from in here somewhere all the way down to the axis. I'm going to draw that axis in because that probably didn't work. This line's probably still floating, so we'll make those collinear. Now I'm going to dimension. That is 4.76. And then the thickness is 0.62 in here. So the thickness from here to here, 0.62. Now I'm going to cut revolve that. Don't put that little notch in there. I want you to do that as a separate feature. It'll be a rectangle that you will sketch. I'm not going to do that here. So we'll revolve cut. 360 degrees, hit OK. There's that pocket. Now I'm not going to do the little notch there. I am going to, however, go to a right side view and switch this to wireframe. We probably haven't played with this much at all, but we can switch between solid looking part or wireframe in different views, and I want to see all that internal geometry. So I'm going to start a sketch on the right plane. I do want to show you, we're going to do this one hole the hard way, and after that, starting I think next week, we're going to start Hole Wizard holes. But this one we're going to do the hard way. So if you've used Hole Wizard, too bad. You got to do this one the hard way. So I'm starting a sketch on the right plane. I'm going to draw first of all, a center line through here. I'm going to stick it way out the end here. Then I'm going to draw half the hole. You should be excited right now because this is the only assignment this semester where I'm going to allow you to do math. This hole, if I bring this on screen a little bit, this hole has a 70-degree countersink. Not a very common countersink these days. But because we're creating half, I'm going to let you divide that by 2 to get this dimension. It's the only case where I'm going to let you do that this semester. You could get it done with geometry, but I'm not going to make you do that. All right, so we want a smart dimension. We're going to get the hole diameter first. That's 0.375. We're going to get the countersink diameter in here. That's 0.75. We're going to put the angle in now, so between here and here, this is 35. Be careful where you put that dimension. Make sure you get it in the right place. Don't make this 35. That's not correct. So do be careful with that 35 millimeter dimension. Now, I need a diameter dimension of 312 to establish the position of this. So I'm going to put another center line in here off the origin. This is the trickiest dimension of all, smart dimension. If I pick a center line and a center line, now watch, I'll fix this. Nope, it won't give me the diameter. So when you smart dimension, you have to go from the object line here, the solid line, to the center line, and then you can get the diameter dimension of 3.112. Notice my sketch is now fully defined almost, except I have a line that's not vertical here. So let's fix that. I think I'm fully defined now. Now, this drawing has 2 center lines in it. Move that over. Center line here, center line here. When I do a cut revolve, SolidWorks won't know which one to use, and you're going to have to tell it. So I'm going to do that ahead of time. I'm going to select that center line because I want my little cut revolve to happen right here. And we're going to feature, revolve cut. You can see the preview in yellow there, and we'll hit OK. And that put that countersunk hole in there. Finally, I need to pattern that hole. I've got 3 of them. They're equally spaced. So I need to show you the circular pattern tool. We have not used that yet. So another new tool. So I'm going to click on circular pattern. It's underneath the linear pattern tool. And right here in this box, doesn't tell you unless you mouse over it, but you can see it's popped up. It needs a pattern axis. That's what this means. Pattern axis. Well, there is no axis showing here. I have to turn it on. So let me show you that. This is the show toolbar. And these are all the things that it will show you. It'll show you planes and origins and sketches and whatever. These are temporary axes. And any circular feature or cylindrical feature has a temporary axis. So I'm going to turn that on, and you can see that I now have 2 axes. I have one for the hole, and I have one for the middle of the part. So for my axis, I'm going to pick the middle of the part because that's where the pattern goes. I'm going to say equal spaced, and I need 3 of them, but I haven't told it what to pattern. Down here, features to pattern. 2 choices. I can click on that countersink. It would probably grab it. Or I'm going to click on the plus mark here and hit that bottom cut revolve. And now I see 3 holes on a 312 diameter there that we put in as a dimension before, equally spaced, and I'll hit OK. And there's our circular pattern. I'll go back to a kind of shaded view. I didn't cut the hole in. That's a cut revolve. I didn't cut the groove in. I'm going to let you do those, but that's how we create that part. So there you have it, week 2, part 2, and as always, enjoy.